Hello, welcome to this lecture. In this lecture, we are going to analyze the builder design pattern. We are going to present how to encapsulate object creation in our builder object. The goals for this lecture is to present a little motivation example, then we are going to describe the builder design pattern, and we are going to see some uses and which is the power of the builder design pattern in action. Well, what is the objective of the builder pattern? The idea is that we are going to create an object, our builder, that will help us to create a complex set of objects. Usually creating objects start to get more and more complex when we have more and more interaction between these objects. When we create a graph of objects and these objects start having reference between each other, it's more and more complex. It's easy when we create a single object, but for a given task, we are going to start having a more and more complex graph of objects of different type, with different configurations, and with different values for all of them. Creating this graph of objects can take a lot of time. Also, we want to encapsulate this creation from the user. So later, we can modify this graph of objects, adding new objects or adding variations in this graph without modifying the client. So we want to modify this graph of objects without affecting the client. We want to change it under the user's feed. Also, we want to expose an API that is closer to the client of our code, that express what the client is waiting and not what the objects we need to create or how they are created or have the relationship between each of them. So we need to provide an API that is closer what the user wants to use. If we read the motivation of the builder design pattern in the Gang of Four book, in the design pattern book, we see that the idea is that we want to separate the construction of complex objects, of complex graph of objects from the user and encapsulate the internal representation of them, how they are built, how they are connected between each other, what are the relationships, their internal values, and we can have with it different representation. Because, for example, we can expose, using the same builder API, two different representations of the same objects or two different representations of objects to do the same task. For the user, this will be all transparent. The idea is that we are going to verify the construction of a complex graph of objects in an object. As we said, the builder has the specific idea of representing the building of the other objects, the creation of other objects. Encapsulates this creation logic, ensures that the objects that we are creating are well created, that all the values are well set, that all the references are well set, and that we are always having a good graph of objects that we can use for the given task that we want. This decoupling of the creation, of the procedure of creation and the client allows us to have different backends, what is called different backends, that basically is to have different kinds of objects as a result. The idea of this is that our client will talk always with our builder, and the builder can produce or a set of representation or another representation completely different. But to the client, it will be completely transparent because this is encapsulated into the builder. For example, we can analyze the idea of creating settings in Pharo. In Pharo, we have a nice settings framework that allows us to configure different parts of the system. But the idea is that the users does not know how to create this complex setting object. They are just asking what are the elements that they want to set. In this case, we are going to set the instance variable microdown and comment, And we are going to establish a label, a default value, and which is the object that holds that instance variable. As we see, the builder, in this case, the most important part is that the API talks about what the client is wanting to do. In this case, exposing a setting to the setting configuration, and does not say, is not caring about this. When we produce it, when we execute it, it will generate a checkbox with the label that we pass, and when we click on it, it will set this instance value to the right value. All this behavior is hidden from the client. The client only describes what it wants, and the builder creates all the complex elements behind. As we see, the setting node builder, that is what we were analyzing before, just understand messages to be configured. In this case, to give a default value to the setting, to have a category for it. If we have different possible values, we can give a domain value, and in this case, it will produce a drop-down list with the different values. If we want to give an icon, if we want to give a label, we are configuring what we want and not how it is created. This setting builder has a really nice feature, is that the first is that we can express what we want as in a DSL. The users of the settings builder don't care how this is implemented, but just how to demand things to the builder. We don't need to have all the creations of setting objects hard-coded all in our code, all in our domain. We only use the builder. The builder will guarantee that what we create is really nice and well done, so we don't need to care to have problems because we put one object inside another that it was not intended to. And all this creation is completely encapsulated from the user. And like that, the user can have the attention in other parts of the code, and it's the setting builder who has all the creation logic. We can see another example of a builder that we have in Pharo is the use of microdown. Microdown allows us to create documentation pages or text pages with a rich text model, when we can have different elements like, for example, code blocks, or we can have lists, or we can have links and titles. So it allows us to create a rich text model. Of course, this rich text model is backed by a graph of objects behind, but we don't want to create them by hand. So microdown exposes a builder API that works in the same sense. In this case, the builder API talks about the elements that the user of the builder want to talks about code blocks, talks about comments, talks about if the text is in italic or not, if it's an anchor, if it's bold. So it talks about the elements, talks about the concepts that the user want to set in the API. Does not talk about the objects that is created inside. That is completely hidden. If we see an example of how to use this, in this really little example, we see that when we are creating the text object, the microdown text object, we are using the builder, and we are talking to the builder in the terms that we know about in this case, about the microdown text. We don't care about what objects are used to create it, or what is the final result of the string that we have in our test. So for the user, it's better to use these messages to talk in the sense of what we want, and then the builder is at the end generating the text and this microdown text representation. As I said before, it's important to see that the API of a builder is the most important part. In the case of microdown builder, the high-level API encapsulates all the complexity of the microdown itself. The users are directly using it without needing to do any extreme manipulation, and talks in the terms that are implemented by microdown. And also, one important thing is that how microdown is implemented inside is completely transparent to the user. The user only talks to the high-level API. Let's see another example, because we want to really put effort in understanding the importance of the builder API. We have Seaside. Seaside is our web framework that allows us to produce nice web examples using a really beautiful builder API. It will generate an HTML page without having to do any kind of string manipulation, not having to care about the correct structure, because as you might know, HTML pages requires to be correctly structured and correctly created to be correctly rendered in the browser. So in the Seaside builder, again, if we see the messages that we send to it, we see that we are talking in the terms that are understandable for the user. In this case, we are talking about headings, paragraph, list items. We are creating an ordered list here. So all these elements are completely understandable for somebody that wants to generate an HTML page, and also provides a way of easily generating them without caring about string manipulation. Moreover, this Seaside builder provides us with a way of structuring elements that should be inside another. All the list item elements should be inside an ordered list element, and the API of the builder provides us with a way of correctly ordering them. This DSL-like syntax makes that our builder is clear to understand, and we can see clearly that this list item that we are creating is inside the ordered list that we are generating. When to apply the builder design pattern? Well, we want to apply the builder design pattern when we have some kind of a regular object creation. We have some regularity in the object creation, and we want to use it in different places of our application, or we have different users of it. As for example, in the Seaside example, we will have many applications generating HTML using the builder. So we want to use a builder to hide the complexity. The builders give us a single entry point to the creation of objects. So it is a really nice feature of a builder. So we can create complex objects in a single way. And if we need to change it in the future, we control this single entry point. Also, the builder has a clear API that is used by the users. So this API gives us a stable point where we can implement an evolving solution without changing the API. As I said before, the builder encapsulates the implementation, so it hides the real implementation from the user, so we can always evolve the implementation without affecting our users. As a conclusion, the builder represents and controls the creations of objects. It encapsulates this creation logic. We are always sure that we have a well-created graph of objects, and we have a decoupling between what the user asks to the builder and what are the real objects that are instantiated at the end. And this gives us a way of decoupling evolution, because we can evolve always the implementation without affecting the users of it.